We ended semester 1 becoming experts on compounds, ionic versus covalent. We knew characteristics of both of them, and we especially knew the nomenclature. So when I say the nomenclature, I mean if I wrote the word dihydrogen monoxide, you are able to turn dihydrogen monoxide into a formula. Is that ionic or covalent? It's covalent because only covalent use these prefixes. Remember, the bigger trait of covalent was that they're two nonmetals bonded to each other. But in the first word, I see hydrogen. In the second word, I see oxide, which is really oxygen, just ending in IDE. The prefix di means what number? The prefix mono means what number? So it was a fun way of saying water, dihydrogen monoxide. But anyhow, that was kind of the basic skills that we were ending with first semester. What we're going to start off doing this semester is applying numerics, quantitative analysis to the compounds. And we start as simple as we can go. If you look at your new cheat sheet, molar mass is our first topic. And what molar mass is defined as, molar mass is the total mass of a compound, found by adding up its parts. In other words, if we go and look at hydrogen's mass and oxygen's mass, of course they're found on the periodic table, we can just add them together to get the mass of water. However, you've got to account for how many of the items that there are. All right, so there's not just one hydrogen, there's two hydrogens. So you'd have to take the mass of hydrogen, well, twice, and then the mass of oxygen once, add it all up, and you're done. So, let's take a look at what a first molar mass problem might look like. We are going to use water as our first example. I just going to make it look a little cleaner. The question is, what's the molar mass of water? How much does he weigh? If you look at your cheat sheet, I break down the steps for you. It says, step 1, list each element of the compound. Water is made up of two elements. I'm going to make a list, hydrogen and oxygen. Step 2 says count the number of elements present for each compound. I just went over this, but how many hydrogens are there? There's 2. Does everybody see why there's 2 hydrogens? 2 hydrogens. How many oxygens are there? There's 1. Remember, if there's no subscript, it's a 1. Step 3, multiply, all right, multiply the periodic table masses of those elements. And now we're going to go and start getting those decimal numbers that live on the periodic table. The molar mass of hydrogen, looking here, is 1.008. Do you see where I get 1.008? What's oxygen's? 15.999. You'll memorize that one. You'll memorize a bunch of them on accident. You don't have to memorize them. But oxygen is in a lot of compounds. So we need this secondary value, and that's when the calculator becomes your buddy. But 2 times 1.008 is 2.016. 1.15.999, or times rather, is of course the same number. And now we have finished that step. There's one more step. It says add those numbers together. What is 2.016 plus 15.999? .015, is that what you get? The units for molar mass is grams per mole. So make sure you understand the simplicity to what we've actually done. We've said if I have one water, it's going to have a mass of 18.015. I just added up the sum of its parts. However, there's a secondary skill that we can apply to this, and it's called percent composition. We're going to do a bunch of examples. We'll do more molar mass, but just to introduce both concepts at the same time. Molar mass is adding up the parts. Percent composition is seeing, well, what percentage does each element make up of the compound? For example, you might be surprised to see that even though there's only one oxygen, the majority of water is still oxygen. And let me show you what I mean. If you go to the next section on your cheat sheet, it tells you how to find percent composition. We're going to see what percentage of water is hydrogen and what percentage of water is oxygen. And again, it's got steps listed there for you. Step 1 says find molar mass. That's what we just did. You can't find percent composition without first getting that number, the molar mass. So let's move to step 2. It says divide each element's individual total mass by the molar mass. All right, well, let's take a look at that. Hydrogen's individual molar mass was 2.016. 2.016. It said that we want to divide hydrogen's number by the molar mass, the big number, that final number that we got while we were doing that first process. So there's hydrogen, 2.016 divided by 18.015, and then it says, what's that last step? Times 100. Plug that into your calculator. Plug that blue stuff into your calculator. I don't have a calculator yet. We're going to go 2 numbers past the decimal. What do you get? Oh, come on, wake up, wake up, wake up. This will take forever. What do you get? There we go, 11.19. Even though water has 2 hydrogens in it, only about 11% of the molecule is made up of hydrogen. So let's go and see what percentage the oxygen is. All right, same process. It says that we need to divide oxygen's total, which was 15.999. Remember, there was only one of him. We need to divide that by, again, you always divide by the molar mass, that biggest number. 18.015 times 100. I get 88.81% oxygen. And one way you can check your answers on the percent composition part is that these two values should equal 100% or very, very close to it. Sometimes rounding will make it 99.99%. But all right, so that was a big pill to swallow. That was a long process, but I think that you'll think it's easy once we start a new one from scratch. Water has a mass of 18, but only 11% of it is hydrogen, and about 89% of it is oxygen. Those are all the conclusions we can draw. Let's do another one. Can I erase this? Write this down. Ammonium telluride. Just so we remember the process of creating a formula, ammonium is NH4. Telluride, ending in IDE, is really an element on the periodic table. It's tellurium. Ammonium has an oxidation state of +1. This is review. Tellurium, -2. Not crazy, right? What do you do when those two numbers are different? You crisscross them. That means ammonium, which is polyatomic, is receiving a 2. So parentheses are necessary. And tellurium received a 1. We don't show 1s. And there's our formula. If you have no recollection on how to do what I just did, then you need to come to tutoring, which is held every single morning in this room. Come see me. This will be the next formula that we are about to analyze. I just need more space. You're fine. All right, there he is, ammonium telluride. First, let's pretend that the question is, what's the molar mass? Step 1 to finding the molar mass is to list out all the elements. I see nitrogen. I see hydrogen. And I see tellurium. Of course, the capital letters are the best place to start. They show you where all the elements are. Reading off your cheat sheet, you don't have to have these steps memorized yet. Next, we need to count them. Now, we've got a parentheses thing going on here that we need to investigate real quick. In algebra, you have the distributive property where a number outside parentheses multiplies individually times everything inside parentheses. All right, your pre-algebra is a prerequisite for my class, so hopefully this isn't a shock to you. But you see that little 2 right there? He's going to multiply into the parentheses times each capital letter that's there. So even though there's only 1 nitrogen right there, it's going to be 2 times that 1 nitrogen. How many total nitrogens are there? There's 2. How many total hydrogens are there? 2 times 4 is 8. And for those of y'all that want to see it a different way, this is saying that there's 2 NH4s. So it would be an NH4 and an NH4. All right, there's 2 NH4s. There's 2 N's and 4 H's, and 4 H's is 8 H's. So that's what's really happening there. How many telluriums are there? Yeah, there's only 1. That tellurium is completely unaffected by all that other stuff that's happening before it. He's not in the parentheses. Step 3, find the masses and multiply. So we need to multiply all of these guys times their periodic table masses. Let's go find them. Nitrogen has a listed mass of 14.007. If I throw a number up here that's wrong, just yell at me. I do that sometimes. Hydrogen has a PT mass of 1.008. Tellurium, I don't know that one. 127.6, thank you. Let's find those values. All right, I work kind of slow. I bet you can beat me to them. 2 nitrogens looks like it's going to come out to 28.014. 8 hydrogens looks like it'll be 8.064. And my tellurium won't change. There's only one of him. Please stop me if anything I do does not make sense. Remember, we're just trying to find molar mass right now, the total mass of this compound. To do that, we will add 28.014 plus 8.064 plus 127.6. Who's got a value for me? Yeah, I get 163.68. I round. Let's just go 2 numbers past the decimal for now. What are the units of molar mass? Grams per mole. Now, I know you don't know what a mole is yet. A week from today, I'm going to make you sick with moles. All right? But for right now, take my word for it. This is grams per mole. There he is, the molar mass. We good right now? Hey, look at that online assignment up there that says molar mass. All 11 questions on that assignment only want you to go this far. You get to stop right here and go on to the next question. But the second assignment is a little more annoying. There's only 8 questions there because they don't want you to stop here. It wants you to then find percent composition. The percentages, so let's snap into that. Just continue down on your cheat sheet. To find percent composition, divide these numbers, each of them, by that big number, times 100. So nitrogen, 28.014 divided by 163.68 times 100, right? His individual mass divided by the molar mass times 100. I'm going to get the other work written. My brain works better like that. Hydrogen, his total was 8.064. Again, always divided by that biggest number times 100. Tellurium was 127.6 divided by the molar mass times 100. Let's see what percentages we get. 28.014 divided by 163.68 times 100. Again, we're going to round to 2 numbers past the decimal. I get 17.12%. I see y'all clicking away, but make sure that while you look up here, ask a question if something's not working. Hydrogen, 8.064 divided by 163.68 times 100. I get 4.93%. And the last one. I get 77.96% for the other one. Now remember, these percentages, if you did all of this stuff right, should add up to 100% or 100th over. These actually add up to 100.01%, which is fine. It's because we rounded. Which of these elements of ammonium telluride is present in the least percentage? Hydrogen. Only about 5% of the compound is hydrogen. But you might not know that just by looking at the original formula. To the naked eye, it looks like there's more hydrogen than anything. But hydrogen's so light that almost the whole compound is tellurium. Because even though there's only one of them, he's big. So you've got to go through this process in order to answer some of the analytical questions I can ask you about your numbers. What do you think? Let's keep going. Two more I want to do today. Our next one is barium chloride. Again, I want to review the writing the formula part with you so that you can have that moment where you realize you might really need to come to tutoring. Barium is Ba on the periodic table. Chlorite, ending in ITE, is polyatomic. He's on that list that I will still give you, but the polyatomic list says that he is ClO2. Some of y'all have that list, some of you don't. I'll get one to you if you're missing it. Barium has a predicted charge of +2. Chlorite on the polyatomic list is listed as -1. The numbers are different, so we will crisscross them. 1 barium, we don't show ones. Here's a number bigger than 1 being crisscrossed to a polyatomic, so parentheses are necessary. Let's find the molar mass. Step 1, break it apart. Ba, Cl, and O. Step 2, count them. How many bariums are there? How many bariums are there? How many bariums are there? Come on, come on. I keep yelling louder and louder and louder. Look here, wake up. Talk to me. How many bariums are there? 1. Yay. There's only 1. All right. He's not inside the parentheses, so this guy's not going to distribute to him. How many chlorines are there? 2. There's 2. 2 times 1 is 2 chlorines. How many oxygens are there? There's 4. 2 times 2 is 4. Multiply those elements times the masses. Barium has a PT mass of 137.328. Chlorine has a PT mass of 18.998. Oxygen, 15.999. Run the numbers. Barium won't change. Chlorine will. $37.996. Four oxygens. 63.996. Add them all up for the molar mass. 137.328 plus 37.996 plus 63.996. I get 239.32. Yes, sir. Is it? Dun, dun, dun. This one here?
Yes.
One chlorine is 18.998. Oh, I'm doing fluorine. That's what. Thank y'all. Those were really good numbers for fluorine, though. Let's run that guy again. My apologies. Fluorine's listed at 35, not 18. So 2 times 35.453. You'll get a larger number than we were dealing with a moment ago. What do you get for the molar mass? Yeah, that's what I get to now. 272.32. Make sure you put units on these steps. Get in that habit. The units of molar mass is grams per mole. Units of percent composition is just a percentage sign. So there he is, molar mass. If we were doing assignment 1, we'd be done. Let's pretend we're doing assignment 2. To find percent composition, let's divide. 137.328. Divided by always the biggest number, molar mass, 272.32 times 100. I'm going to go through and do all the numbers again. Chlorine was 70.906. Always dividing by the same number. Oxygen, 63.996. Get our percentages. 137.328 divided by 272.32 times 100, as we wrote there. I get 50.43%. Chlorine, 70.906 divided by 272.32 times 100, 26.04%. And there's there's some of you that will get really brave, and instead of working out this last one, you'll take the difference from 100%, knowing that that one should get you to 100%. If you really trust yourself, you can do that. But 63.996 divided by 272.32 times 100, 23.5. What do you think about this?